Hey guys, today we're going to talk about solving triangles through using the law of cosines. Okay, so we've learned about the law of sines, and now I want us to go over the law of cosines. Alright, so here's just a learning target and an essential question if you want to write it down. But let's go ahead and dive right in because you can pause the video and write this down if you need to. Okay? Here is the law of cosines. So the law of cosines is basically the idea that I'm given some triangle, alright, I can say that a side length squared is equal to the other two sides squared minus 2 times the length of these two sides that I'm given times cosine of the angle opposite of the side I'm trying to find. So let's walk that through with this idea. Let's say I'm trying to find little a right here. Okay? Well, if I also know side B and C and the angle opposite A, I could use this idea right here. I could say, okay, little a squared is equal to little b squared plus little c squared minus 2 times b times c times cosine of angle A. And that's true all across the board. Okay, you can say that for little b squared, if you're given the other two sides and the angle opposite b, little b, if you're given this angle over here, then you could use the law of cosines again. Alright, and you just set up the same way. Down here, this is the same formula, I just worked it out for you so that way you could always, let's say I said solve for an angle, and we'll do an example like that in a second. But if I said solve for an angle, that way rather than having to solve for cosine A over here and move everything over, I've already moved it over for you. So I've already set it up so all you have to do is plug in all the information and inverse cosine to get the angle you need. Alright, and we'll do a problem like that. Let's dive in. So, first off, we have this triangle right here, and the instructions tell us to find side BC. I look at this and I say, okay, that's not a right triangle, so I cannot use Pythagorean theorem. You might be tempted to. I know two sides, but it's not a right triangle, so I can't use Pythagorean theorem. Alright, not a problem. What about trig ratios? Oh, it's not a right triangle. Well, now, if I can't use either one of those, the next thing I tell you how to do is to draw that little table. And we're going to do the same thing. We're going to say sides, and we're going to say angles. Okay, so we draw ourselves our little T-chart of this. And then so we have side little a, side little b, side little c. Alright, side little a, well that's actually the side I'm trying to find. So I'm going to put a question mark there because that works for me. Side little b, that's the side across, so that's 21. Side little c, that's the side across from angle C, so that would be length 30. So then capital A, that's the angle 123. Little b, I don't know, and little c, I don't know. Okay, so let me ask you this question. Do you have a pair of opposites? That was what was necessary to have to use law of sines. Look for here, do you have a pair of opposites? I do not know little a, I know capital A, but I don't know little a. I know little b, but I don't know what should be big B. I know little c, but I do not know what should be little c. Okay? So then you'd say, no, we don't have a pair of opposites, so we cannot use law of sines. This is where law of cosines comes into play. You must know two sides, always. If you want to write something down to use law of cosines, you could write down, I must always know two sides, a minimum of two sides. If you're solving for an angle, you actually have to know all three sides. But to use law of cosines, you must know a minimum of two sides, and you must know, well, let me get rid of that last part. I was about to say something that's not really a great statement. So instead, I'll just say, you must have a minimum of two sides. I have two sides. Since I'm solving for a third side, I need to have the angle opposite it, which I do have. So this is a law of cosine situation, okay? So law of cosine said the side, and you can flip back, you should have written this down. The side I'm trying to find squared, so that would be little a in this situation, little a squared is equal to, so little a squared is equal to the other two sides summed up and squared, so 21 squared, because that's little b, 21 squared, plus 30 squared, minus 2 times BC, so 21 times 30, times cosine of the angle opposite the side I'm trying to find. So in this case, cosine of capital A, which is 123. So then, this is definitely a situation that I can plug all this side into my calculator in one go. So I can type into my calculator. Let me see if it turns on. This wastes so much time trying to get this stupid calculator to turn on. Okay, 21 squared plus 30 squared minus 2 times 21 times 30 times cosine of the angle 123 degrees. Before I click enter, I'm going to check my degree mode. Make sure I'm in degree mode. I am. So then I go back to this and I press enter. So a squared is equal to that number. So a squared is equal to that number. Well, I want just a, so what am I going to have to do to this number to get just a? That's right, I'm just going to square root it. So second square root. Oh, that did not work. I thought that gave me something. Oh, okay, here's how you do it. Second square root, and then second answer. You guys have fancier calculators, so you can just, use your up arrow, press enter, and it'll automatically populate it. I, on the other hand, do not have that option, so I use square root answer, and I get that little a is approximately 45.02. So a is approximately 45.02. And there you go. That's how you use law of cosines. Alright, my suggestion to you is you stop right now in your notes and you write a summary of each step. Really write it out. Think through, okay? Try to pause this video and write out a summary of what just happened. So hopefully you just unpause the video and you're coming back. Oh, I did not want to do that. So hopefully you just unpause the video and you're coming back now and you're kind of like, okay, what's next? I'm understanding this. I'm ready to rock and roll to our next problem. So let's dive into our next example. Gives us a triangle. This time it says find the measurement of angle C. Just not to waste time. It's not a right triangle. We're gonna have to use. We're gonna have to set up our table. Okay. So sides and angles. Okay. So I have side little a, little b, little c, and then I have angle capital A, capital B, capital C. So side little a is the side across from angle A, so that'd be 29. Side little b is the side I do not know, so I'm going to put a question mark there. Side little c is 24. Okay. Capital angle A, I do not know. Capital angle B, I do know, 101 degrees. And capital angle C, I do not know. In fact, that's actually what I'm trying to solve for. I may have put an extra question mark in this problem. I didn't. I'm going to talk about it. So first, if I want to find angle C, let's go back and look at the formula. Well, first off, I'm sorry. Do we have a pair of opposites? No, no, no. Okay, so it's not law of sines. So that means that it's got to be law of cosines, because it's not a right triangle, it's not law of sines, so it's got to be law of cosines. So let's go back here and let's see. To find an angle, I have to know side A. So, oh, this should be squared. I guess I cut it off. All right. I have to know side A, side B, and side C. Well, wait. Do I know all those sides? Do I know all three sides? No. So at the moment, I cannot use law of cosines to find a missing angle. But I could use law of cosines twice. All right. Here's what I mean by that. Look here. Do you know two sides? Yes. Do you know the angle opposite the side you don't know? Yes. You can use law of cosines to first find this side and then use all three sides to find this angle. I'll explain. Alright, let's start off by using law of cosines to find this side right here. So I would say that b squared is equal to the other two sides squared and added together minus the two sides times 2, so 24, 29, times cosine of the angle opposite the side I'm trying to find. So now that this is a calculator situation, so I say 29 squared plus 24 squared minus 2 times 24 times 29 times cosine of 101, and I already made sure it was in degree mode earlier, so I'm good about that. So this is what b squared equals. So then I square root this number to get what B is equal to, which is 41.02. So I get that B is approximately 41.02. I can now use this to find my missing angle. So I can say cosine of angle C is equal to, okay, let's jump back, is equal to a squared plus b squared minus c squared. So what that is the side not opposite squared plus the side not opposite this angle squared minus the side opposite this angle squared. So what I mean by that is, so it's the two sides that are not opposite C. Alright, so it's not going to be 24 because 24 is opposite C. So it's 29 and 41.02. So I square them and I add them together. And then minus the side opposite angle C. Alright, so that's minus the side opposite, so that'd be 24 squared. All divided by 2 times the two sides that are not opposite C. So 2 times A, which is 24, and B, which is 41.02. Okay. So this is all going to be one big calculator situation. Alright. I'm going to take y'all through Desmos real fast just because I think that's actually going to work faster for me. Alright, so let's see here. dsmos.com. I'm going to say scientific. Okay, I'm going to jump around just for a quick second. So I'm going to say 29 squared plus 41.02 squared. So first, I'm going to hit division sign to make sure that fraction comes up. 29 squared plus 41. How do you delete something on this? That's not really what I wanted, but that's just what happened. No, okay. I don't know what's going on here. 29 squared plus 41.02 squared minus 24 squared divided by, if I'm not mistaken, it's 2 times 29 times 41.02. Let me double check that I did that right. Yes, I did. And that's what I get. Now, let's be very clear. Cosine C equaled that number. So cosine C equaled that 0.8 something number. Okay? That's what cosine of angle C equaled. It equaled the 0.812, something like that. I had to double check. Okay? I don't want cosine C. I want just C. So how do I get rid of cosine? I take the inverse of it. So I have this number. Okay? So I'm going to copy it. I wonder if I can't just get it to like become a number I can deal with. Nope, that's not what I wanted. Okay. So then I hit function, cosine raised to -1, control V, and I get 35.05. So the angle I need, angle C, is 35.05. So the measurement of angle C is approximately 35.05 degrees. Alright, okay guys, that's the end of this video. I'm trying to wrap it up kind of quick. Please let me know what questions you have. Hope you guys have a great day.